Record. Okay. So our next speaker is Bens Halpern, and he's going to talk about predicting and synthesizing plausible speech examples after oral cancer treatment. Bens, I give you just the microphone.
Thank you. Yeah, thank you for the introduction. Hello, everyone. I'm going to talk about predicting and synthesizing plausible speech examples after oral cancer treatment. This was my research in the last 4 years, but I'm mainly going to talk about the last piece of my research. So, well, let me introduce, if I can step in the slides, let me introduce what's the general idea behind our research aim. So why do we want to synthesize these plausible pathological speech examples? The reason for that is that we experience in the hospital that patients want to know their postoperative voice. If doctors do not show them, they will be stressed, and we know that stress is going to have an effect on the general quality of life, even in the short term, but also in the long term. So we think that speech synthesis, pathological speech synthesis, could be used to basically show them how they will sound after a surgery. So today I'm going to focus in like one particular approach on how to achieve that, basically an approach using articulatory synthesis. And now with this diagram, I'm going to show how the entire framework is laid out. So, which is sort of still a hypothetical ideal scenario. First, we would have this biomechanical model, which we could use to simulate a surgery on the tongue. And using that simulation, we would be able to obtain basically tracker points from this tongue, which show how the tongue and certain points inside the vocal tract basically move, and based on that we have an articulatory synthesis network that would be able to synthesize speech of the patient. But that wouldn't be specific to the patient itself. Therefore, we need a voice conversion model to make it specific to the patient, to sound like the patient. So today I'm going to synthesize on the middle part of this framework, which is articulatory synthesis. But basically, the sort of idea that we want to reach using this framework is that once we hear the voice samples at the very end of this pipeline, we can use that to adjust the biomechanical model, which is a simulation of the surgery, and do this in loops to reach the best functional outcome. So essentially, the end result would be an explainable framework. However, it has the disadvantage that getting the right data for this is actually pretty difficult. So for that reason, we teamed up with the speech lab in Groningen to record parallel electromagnetic articulography data and speech recordings. In this analysis, in this study, we used 2 controls and 5 pathological speakers, and we had approximately around 30 minutes of data from each speaker. So I must point out that this study was quite ambitious in the sense that most of these electromagnetic articulatory recordings were done on healthy speakers. So during the experimentation, we faced interesting problems in the sense that, okay, we have to stick an electrode on the tongue, but sometimes oral cancer speakers' mouth is so dry, or some pieces are missing from the tongue. Therefore, it's very difficult sometimes to do that. And it was, I think, this study was unique and ambitious, I think, in that sense. So we recorded this data, and the idea is that using this electromagnetic articulatory data, we can use that to synthesize speech. There are already existing articulatory synthesis neural networks And what I have basically done is a modernization and combination of best practices from these networks to kind of keep up with today's standards of what we call a neural network. So to give an example of that, some of these networks are still using layer-wise pre-training, and I sort of changed these techniques to be more up to date with today's neural network standards. Basically, this resulted in this 4-layer LSTM and neural network, which we use to obtain the acoustic features for the waveform resynthesis. The source code is available online, so you can also check it, but it's not using the patient data, but publicly available data. So the first question that we wanted to look at using this framework is whether it's natural enough. Is it possible to synthesize high quality oral cancer speech using articulatory synthesis? And for that reason, we compared real pathological speech to synthetic pathological speech. But we also wanted to look at the scenario that, yes, it's likely going to be difficult to do that, but is it the pathological aspect that's making it difficult? So is there like a general bias problem? Is it more difficult to synthesize articulatory synthesis, using articulatory synthesis pathological speech than to synthesize healthy speech? So that's what we assess by comparing the naturalness of synthetic healthy speech to synthetic pathological speech. To do that, we used a standard naturalness evaluation test using 10 Dutch listeners. These were mostly inside of the hospital because we couldn't share the speech samples with people outside of the hospital. And also, so which means that there is a mismatch between the speaker's dialect and the listener's dialect. And the task was simply to rate the naturalness of the utterances using this 5-point scale. This is usually the standard listening exercise for speech synthesis evaluation. And if you have never seen anything like that, this is basically a Likert scale. Right, so these are the results, and what we have of results for the naturalness of the pathological speakers. The top row contains the ground truth and the lower row contains the predicted, so the synthesis results, and it is shown speaker-wise. And what you can see is that the pathological speech itself is perceived quite unnatural. So for example, the healthy speech received 4.81 on the 5-point scale, which means that even the fact that the pathological speech is not healthy affects the naturalness affects the evaluation in this questionnaire. But what we also see is that there is a significant decrease of 1.72 points. So naturalness is still not comparable to the ground truth. So as I mentioned, I wanted to look at that. Is this something that's more related to what the technology is currently, or is it also a bias issue? And we do find that there is a difference of 0.33 in mean opinion score, but this is statistically not significant. So we are not sure if there is a real effect there. And the difference might still be because even the natural samples are rated, even the natural pathological samples are rated lower. So it could be either that there is a bias problem or either there isn't, because the effect is not significant, but it's also unclear what would be the effect in this case. Is it more the bias problem or is it more an evaluation problem? Yeah, so based on these findings, we think that the first thing that we think is we would likely need a new subjective questionnaire that measures the naturalness with pathological speakers. That's irrespective of speech severity. But in the more general discussion of the mean opinion score, we would likely need a definition of naturalness that's less relevant on demographic factors such as gender and nationality, and move away from this more enjoyability definition of the mean opinion score. And the second thing is is that we still see this significant decrease of 1.72 points. And we think that the key issue here is basically data scarcity. We haven't had a lot of data to train this network. And we also think that's the main reason, because using the public data set, we have achieved a lot better naturalness resources. So likely for future work, the way to improve would be to use speaker-independent articulatory synthesis, which would increase the amount of data fivefold, or to look into more data augmentation techniques, or a different kind of sequence-to-sequence models. The second question that we wanted to look at is, can we do actual articulatory manipulations? And to answer why it's probably not straightforward what's going on here, but the idea is that if the synthesized speech is natural, it's not necessarily corresponding to it's not necessarily corresponding to the articulatory trajectory that the real text is corresponding to. So I'm sorry. So we wanted to make sure that this correspondence is there, and it doesn't synthesize unnatural, but also entirely different sentence. So yes, that's the point. The synthesis speech can sound natural, but can still be the wrong sentence. So we were interested if we can perform these manipulations on the articulatory trajectory in order to synthesize samples that correspond perceptually to the right voice. And the way that we achieve that is that we record a different variation of the same sentence. So in that case, but with one phoneme difference. So we also recorded it with and and we used one variation of that sentence for training the neural network, and the other variation sentences of that sentence for evaluation. And in that sense, we can check whether the neural network can do manipulation of one phoneme and then synthesize that manipulation. So I think I would have videos here, but maybe because it's Google Drive, it only works on Google Drive, it probably won't work here. But yeah, can I try open it? No, that's not going to work. So, but again, the idea here is that you have the articulatory trajectory. Maybe I go back to the different slide to illustrate it. And maybe if you see my key pointer, it's easier. The blue line would be the original articulatory trajectory we have. The orange line would correspond to the different articulatory trajectory, which has only a single phoneme difference. And we want to hear and see if that gets us to the right modification. And yeah, and what we observe in practice is that in case of we have looked at three separate basically phonetic categories to assess. We have looked at sibilants and three vowels. And what we observed is that sibilant issues are present in oral cancer, but they are also present in articulatory synthesis, and the way they are present is not significantly different. So we think that what's going on is that the articulatory synthesis can actually capture the problems with sibilant production in oral cancer speech. We observe similar thing in case of the vowels. So E seems to be well modeled in case of bit, but boot seems to be confused a lot of times with boot and bit. So that's very interesting, because basically these kind of experiments also inform us about what we need to change in the placement of electrodes. I initially said that this was a difficult thing to do. We weren't sure how to do it sometimes, but the experiment basically tells us at this point that what parts of the tongue, what features of articulation are basically important to correspond during the articulatory measurements and important for high quality articulatory synthesis. So to summarize, there are three main findings and discussion points that we have found. First, we probably need a new subjective questionnaire that measures naturalness, irrespective of the speech severity, gender, and other demographic factors. Second, we would likely need more data or better usage of that data, actually using speaker-independent articulatory synthesis to achieve better naturalness in the articulatory synthesis task. And the last point is that the experiment showed us that we actually need more electrodes on the tongue in order to be able to capture difference and the manipulation in the case of beat booth experiments. I would like to thank you for your attention. Our source code and the related paper is available online if you are interested. Thank you.
Thank you, Bens, for this very interesting presentation. And also, I think you're approaching the problem from with a different approach. So are there any questions?
Thank you for the very interesting presentation. I think I missed one kind of important point. So you have your own speech synthesizer essentially here that you have built, and that's what you have trained. But also you could kind of use this like some of the state of the art, like Google has pretty good speech synthesizer, and you can use SSML, for example, to create like articulatory controls to that. So but would it be possible to do this type of manipulation of articulation based on speech synthesis markup language on standard synthesizers like Google or Amazon and so forth? There's this SSML language that you can
Yeah, I think I think the key problem here is that what we drive the articulatory synthesis network with is the articulatory trajectories themselves. So if we have a way to correspond the SSML markups with the actual articulatory synthesis trajectories, yes, I think that would be possible. But I would have to be more familiar with what kind of notation SSML has for articulatory changes to more directly answer that question. Does it answer your question?
Yeah.
Thanks.
There are more questions.
Thank you. I first have a suggestion, actually. If I was wondering whether we want to take a photo of all participants, and in that case, it might be nice to do in the coffee break rather than later where it's a bit darker. But that wasn't a question. Because I think coffee break's coming up, isn't it? Yeah. Because we have a nice one from the first workshop, don't we? And this is the last one. Anyway, I just wanted to hear your thoughts on the kind of premise here, which is that people want to listen to a voice which is like themselves, because it sounds to me like your research, although it's sort of pilot and early, you were basically sacrificing quality by making sure it sounds like them. And I wonder whether if you had a really high quality model where you can say this is before a general kind of male speaker before, and this is what would happen to his voice, whether you can, as a patient, whether that would be okay, because in some ways, I guess you're also risking if you're showing them something which sounds like them and afterwards they're like, that doesn't sound anything like what I sound like now. People anyway don't like listening to their own voice. So I just wonder whether you know from patients that you're going in a direction of what people actually want. I guess it's a traumatic time for them anyway to sort of be listening to what they exactly might be sounding like, because to their ears, maybe that's not anyway how they sound afterwards. I just wonder whether you have any insights and thoughts on that.
Sorry, I have to walk.
Sorry. If I understand your question right, the question revolves around, okay, what kind of how that would sound. What would it sound like? What kind of speech sample would be interesting for the patient to hear, and I guess also what would be the effect of the speech quality on that, and I think that's a good question. I have approached this from a very pragmatic perspective, that from my point of view, it just has to be very similar to what the patient would have after the surgery, but and I think that's the only realistic option, really. But I might be missing something. Yes. Right. Yeah, I think the whole premise here is that patients are really unsatisfied in general with how we inform them, but we don't inform them well enough how these speech-related side effects would be. So if it's not specific to their speech, I think what they do, and what I think they already do, is that they listen to other oral cancer patients, and oh, it's he or she is not speaking that badly, and we do provide these samples, or I think we do provide examples like that for them. But I think it's the very bit that it has to be similar to you to be really convincing, and to be really make that kind of influence on you, that okay, this could be really me. And the difference is I think in that sense you really have to minimize the difference, and because otherwise the patient has to basically make two thinking steps. The first thinking step is like, how would my voice sound like after my pathology? And then the other bit is the speaker specific bit, which is like, okay, yeah, but maybe if that patient is more severe. So it's I think there are two effects here. That's what I'm trying to say. And I think sort of getting closer to the actual thing would be helpful. And maybe the general model then would be helpful in the sense that it would be more specific to the actual surgery, and not just a generic speech example of someone that was a previous patient at the hospital, for example. Yeah, so in that sense, I think there is maybe a role for a general model, but I think a speaker-specific model would be certainly more convincing. That's, yeah.
Wait, Mara.
Yeah. First, most patients at that stage come with relatives and friends, so there is this near people that can tell you, oh yeah, that is your voice. Second, you present their recording as is next to their recording as it might be, and so they can recognize that this is what I said, this is my timing, my words. People don't recognize their own voice, but they recognize their timing and their intonation. And our hope is that this makes it more personal or more memorable than just some random patient that has something that's different from me, so it is not me. And that's not what, yeah, it's like people who smoke and someone else smokes and dies. That's not me. I won't die. So yeah, that's our hope. We don't know yet.
I was wondering, is there a lot of research about how much information a patient should get prior to surgery or prior to any other treatment, chemoradiotherapy? Because again, yeah, I can see that they need a lot of information and they have a lot of questions, but surviving is the most important factor there. And I'm not sure, I can imagine it has a large impact if you hear yourself with a deviant speech and you know that after surgery, your speech might be not intelligible at all or less intelligible. And then I was wondering, and that's an idea, that maybe it can help that to show or to let them hear a model of how they will sound immediately after treatment, and then maybe after a while of recovery and speech therapy, how it can improve over time as well. But
Thank you for the questions. So the first part of your question was regarding, is there research on how much and what kind of information the patients need? And yeah, there is a bit of research on that. I think mostly on just stating that there is a lack of information, but it's quite detailed on what aspects that information is lacking. So mostly it's lacking in the case of oral cancer with speech, obviously, but also with things like that the patients might become dependent on someone else, how they get financial sources, and basically there is a list of this information online, what they find. And as far as I see, that was basically proposed by the NHS around a decade ago, trying to detect what are the shortcomings. And I think this research in that sense is a larger part of like, okay, how can we provide that information needed? Because from other research, we see that, okay, if they don't get that information, that's going to impact their long-term quality of life, because the treatment is too stressful for them. And your second part of the question was regarding yes, thank you for reminding. There we have a data collection now, which is basically includes partially driven by pragmatic reasons, includes the voice right after the surgery and then 6 months after the surgery. The pragmatic reason is that it's easier to get this kind of data because you can directly get it after the surgery. And the second reason is, I think it's also like managing expectations, because the voice is going to improve, or generally is going to improve over time, and also over speech therapy. Due to speech therapy, it's going to improve a bit. But I agree with you in the sense, because you are shaking your head, that I have done a bit of research on this, and it's always always pointing to two directions. I would say 50% of the research says that it's going to improve. 50% of the research says that it's not clear, and basically there are random improvements and decreases. Depends probably on how we measure it also, which was, I think, a very interesting part of today's discussion. Yeah. Thank you.
I think, like Hedy already mentioned, we all need another coffee. So let's say that we see each other again in 50 minutes. And Bens, thank you once more for your wonderful presentation. Thanks.